Welcome back, STEM students, to part 2 of our lesson. Today, we're going to continue with kinematics related quantities, part 2. This time, we're going to discuss speed versus velocity. As a simple definition, speed is just the rate of change of distance. Okay, so diba nga in our outline, we have um, motion can be described using position, change in position, and the rate of change in position over time. So this part 2 will deal about describing motion using the rate of change in position. And that position can either be distance or displacement. That's why we have this quantities, speed and velocity for each. So we have speed, that's the rate of change of position in terms of distance. When we say rate, that's any quantity divided by time, and it tells us how fast something happens, how much something changes in certain amount of time. Speed is one example of a rate, and it is a measure of how fast something is moving. It is also known as the rate at which distance is covered. Basically, that's just distance over time. In symbols, that's V is equal to D divided by t, meaning since as you may notice, the variables are not in boldface because speed and then distance are uh, scalar quantities. In the equation, the V stands for speed. Remember, remember that it's not S, it's V. D is distance covered and T is time of travel. The possible units for speed are kilometer per hour or kph, meters per minute or miles per hour. So basically any unit of length divided by any unit of time. But the standard or the SI unit is meter per second. Now from our equation here, we can come up with two more equations. So let's say that you have to find the distance given the velocity or the speed rather, the speed and the time. To get that, you just have to use D or distance is equal to speed times time. And let's say naman that given the speed and the distance, you have to get the time. That's just t or time is equal to distance over speed. There are two types of speed, instantaneous and average. When we say instantaneous, that's the speed of an object at an instant measured by speedometer. So the one that measures instantaneous speed is a speedometer. When we say at an instant, for example, you traveled for 3 seconds and at 1 second you traveled 5 meters per second and then you decided to move faster at 2 seconds you become 6 meters per second. So you just consider 1 point in time. So gaano ka kabilis at 1 second? Gaano ka kabilis at 2 seconds? Gaano ka kabilis at 3 seconds? So that's what the uh, instantaneous speed try to describe to us. On the other hand, when we say average speed, that's the total distance covered by an object in a certain period of time or a certain time interval. In average speed, we consider the whole travel already. So instead of determining the speed at specific points in time, here you look at the beginning of the travel and then the end of the travel. You get total distance covered and then the total time of travel, not just 1 point in time and not just one distance. It is the representative speed of the whole course of travel. And then the measuring device that is very useful in getting the average speed is the odometer. So how does that happen? Average speed kasi cannot be measured by a specific device. That's for instantaneous only. So instead of directly measuring it, we will be able to solve for the average speed if we have the odometer. The odometer will get the total distance traveled. And then if you have a timer, you also time your time of travel and then you divide the measurement of the odometer, that's the total distance, by the measurement obtained by your timer. And then you will get average speed from there. Now let's proceed with velocity. By the way, speed is a scalar quantity. Remember that. Velocity, on the other hand, is the rate of change of displacement. Speed is together with distance, while velocity is together with displacement. Basically, velocity is just speed at a given direction. So again, the magnitude of velocity is considered as speed. It is known as the distance traveled in a particular direction in a given time interval. Sabi dito, distance traveled at in a particular direction. Meaning, di ba nga, distance plus direction, that's displacement. Okay? In symbols, that's V is equal to D divided by T, where V, as you will notice, the V and the D are already in boldface, meaning they are vector quantities. The V stands for velocity, the D is for displacement, and then the T, since time is scalar, it is not in boldface, that's the time of travel. Again, velocity is a vector quantity with possible units, kilometer per hour, or in other words, the speed rather has the same possible units and standard units as velocity. So, ang pagkakapareho nila is that they both tell us the rate of change of position. It's just that for speed, it tells us the rate of change of distance rather, and then for velocity naman we have the rate of change of displacement. And then their similarities, another similarity is they have the same possible units, and they also have the same standard unit, any unit of length divided by any unit of time. From the equation again, we can get two more equations. If we want to get the displacement, given the velocity and time, we just have to multiply velocity with time. And then if you want to know the time, given the velocity and displacement, you just have to divide the displacement by velocity. And just like speed, velocity can either be instantaneous or average, but there is no associated device for each one. Instantaneous velocity is just the speed of an object in a particular direction at an instant, while the average velocity is the total displacement of an object in a certain period of time, or it is the representative speed in a particular direction of the whole course of travel. Let's have some questions again. Here, we have Billy walks 5 meters to the east, then walks 3 meters to the west in a combined time of 4 seconds. The question is, what is his speed? The answer is 2 meters per second. How did that happen? We have the equation v, or speed, is equal to distance over time. To get the distance, we just add the magnitudes of the displacements. Kasi these ones are displacement kasi may direction, di ba? And then again, we disregard the directions. We add together the magnitudes. That's 5 meters plus 3. That's 8. And 8 divided by 4 is 2. So 2 meters per second. Same scenario and same given, but this time we are asked for velocity. And then again, we should have the uh, equation, velocity is equal to displacement over time, and to get the displacement, that's solving for the displacement just like how you solve for vectors. That's magnitudes, you subtract the magnitudes, that's 5 minus 3, that's 2, and then you divide it by 4. That's 2 meters divided by 4 seconds, approximately or equal to 1/2 in decimal form. That's 0.5 meters per second. Where did we get the direction east? Again, since 5 is greater than 3, we copy the direction of 5, which is east. That's why the final answer is letter D. Next question, is speed always equal to velocity? The answer is letter C, no, because distance and displacement is not always equal. Remember, distance will only have the same magnitude as displacement if the object is going towards one direction. Pag pa-north lang siya, puro north lang ang travel niya. Pag pa-east lang siya, puro pa-east lang ang kanyang travel, no? So, since distance is a factor for speed and displacement is a factor for displacement, distance and displacement's magnitudes will decide whether speed will be equal to velocity. So again, same condition. The speed will have the same magnitude as velocity if the object is going towards one direction. If the object moves from one direction to the other, the distance will not be equal to displacement. Therefore, the speed will no longer be equal to velocity as well. Let's have and start the first parts of problem solving. This time, we're just going to involve distance, displacement, speed, and velocity. Here are the steps in problem solving. Number 1, identify the given, convert all given to MKS or as standard SI units if necessary, identify what is asked, think of a preliminary quantity that you might need in solving the problem, meaning there are problems wherein before you come up with the final answer, you have to solve for one more quantity which is not given in the problem. Number 4, determine the formulae, or equation that you will need to solve the problem. Number 5, for the solution, you have to substitute and execute, meaning you're going to use your calculator here. And then number 6, you have to evaluate if your answer is reasonable or if it fits what is being asked in the problem. So kapag nag-ask ang problem ng velocity, of course, your answer should have direction. If your problem is just asking for speed, your answer should not have direction. Stuffs like that that you must think of before you stop um, looking at your current problem and moving on to the second one. Let's have the GRESA method as our pattern. G for given, R for required or ask, E is for equation or formula, solution, where you find the substitution, and then the answer or final answer. I have here two examples for speed and velocity. Example number 1, Elma Muros, the fastest female sprinter in the Southeast Asia, can run along a 200-meter distance in 24.42 seconds. And the question is, what is Elma's speed? Let's start with the given. The given are, distance is equal to 2 meters and time is 24.42 seconds. Remember to use the symbols in writing down the given, the equations, the final answers, and even the required instead of writing down the whole name of the quantity. For the required, we are looking for speed, and the symbol for speed is lowercase letter v that is not in boldface. The equation will be speed, or v, is equal to d over t. Let's substitute. That's 200 meters divided by 24.42 seconds. So the final answer would be 8.19 meters per second. So as a standard, we're going to have two numbers after the decimal point pag magsusulat tayo ng final answer. So for example, we have, ang lumabas pala sa calculator mo ay, imagine mo point na lang yan, no? 8.1199. So instead of writing down all those numbers, you may just write 8.12. Ayan, okay? Isa pang example, halimbawa, 215.79611. Ayan. Instead of writing all those numbers, we could write 215.80 because 79, when you round that up, this would be 80 already. So pagkasunod naman nitong 1 na to, this one, if kasunod niya is 1 ulit, 8.11 lang siya. No? I know you already know the rules in rounding off. So you have to round off your final answer, and there should only be 2 numbers after the decimal point. Okay? And then last example, Karen drives to the city to pick up a friend. She went 280 kilometers east in about 9.6 hours. Your task is to calculate her velocity. The given are D or displacement. Remember, kasi meron na siyang direction. Okay? And then look, we're going to look for velocity. That's why we cannot disregard the direction. The direction is important. The partner of velocity is displacement. So the displacement is 280 kilometers east and the time is 9.6 hours. We are looking for V, that is in boldface, to represent velocity. And our equation is V is equal to D divided by T. Then let's just substitute. In substitution, no need to include the direction, just the numerical values or the magnitudes. So that's 280 kilometer divided by 9.6 hours. And then the final answer would be 29.17 kph or kilometer per hour east. So as you will notice, the displacement and the time are not in standard units or SI units because for displacement, the SI unit should be meter, and then for time, we should have seconds instead of hour. Now, why didn't I convert? Because remember, I'm just going to tell you there are two possible reasons why you should convert. Number one, if instead of just one displacement, 280 kilometers, there is another displacement with different units. So let's say that instead of Karen just going through 280 kilometers, he also went 50 meters. So magkaiba sila ng unit. If that's the case, you have to convert the 280 kilometers into meter. That is if the other one is already in standard unit. But what if that's not the given? Let's say that the given is 50 miles. Kilometer and miles are both not in the standard unit. So you have to convert not just the 280 but also the 50 miles towards meter. Okay? Para standard tayo, no? Or pwede rin naman na you convert to one of these. Pero para mas standard tayo, pareho mo na lang silang i-convert, no? The same goes with time. If there are 2 times here, and then the other time, let's say, is 10 seconds, you have to convert the time into seconds. If naman, not 10 seconds, but 10 minutes, you have to convert both of them. Okay? That's the first condition. Kapag marami silang given, maraming given or the same quantity, tapos magkakaiba sila ng unit. Another is if the problem asks you to. Halimbawa, calculate her velocity in meters per second. If that's the case, you have to convert all displacements into meter and all times into seconds. Kapag sinabi niya calculate her velocity in meters per second. O kaya naman, kapag sinabi niya halimbawa mph or miles per hour. Calculate her velocity in miles per hour. You have to convert all displacements into miles and then dahil naka-hour na to, hindi mo na siya i-convert. Okay? Thank you for listening for part 2 of kinematics related quantities. Next, we're going to discuss naman kinematics related quantities part 3. which will be about acceleration.